This is the pretty old CBSE AIPMT 1989 question. That's okay. Don't bother about that. Let's look at the concept. A bus is moving on a straight road towards the north with a uniform speed of 50 kilometer per hour. Let us try to draw what he meant to say. So first we shall know how do we take directions on the paper, right? So in a 2 dimension, that is on a graph sheet, this is x direction, positive x, negative x, positive y, negative y direction. We can take east along the positive x-axis. So negative x-axis becomes automatically west. We can take positive y-axis as north. So that the negative y-axis becomes automatically south. That's how we consider the directions, right? Now he's saying a bus is moving on a straight road towards the north, the uniform speed. So starting from the origin towards the north means this is what he's saying, giving like V1 equal to 50 kilometer per hour. If the speed remains unchanged, that's what is being said. After turning through 90 degree, the increase in the speed of the velocity of that is right. So he has not mentioned actually in which direction. From here it has turned by an angle 90 degree. It could be along any of the way. It could be moving this way 90 degree, or it could be possibly moving on the other direction also, in this way also. We will look into that possibility later, right? So this is v2 speed. The value is still the same. V2 is also 50 kilometer per hour because he said the magnitude is not changed. What is the increase in the velocity of the bus? What is the change in velocity or increase in the velocity? How do I calculate the increase in the velocity? Increase or change in velocity can be written like V2 bar minus V1 bar. I have tried bars because it is given in the format of vectors. What is that V2? This one. So this could be written like 50 minus I cap. Why? X-axis unit vector is plus I cap. Y-axis unit vector is minus I cap. Sorry, negative x-axis. Y-axis unit vector is j cap. Negative unit y-axis minus j cap. The ijk are the unit vectors along x-axis, y-axis and z-axis. That is V2 minus V1. What is V1 is that is towards the north, that is along positive x-axis, that is 50 j cap. So this value is minus 50 I cap minus 50 j cap. You cannot just add both of them because they are along different directions. So to get the velocity, we shall find the magnitude of a vector. Magnitude of a vector is root of x component square plus y component square plus z component square. This is not having any z component. So minus 50 whole square plus minus 50 whole square, that is 50 and 50, there is another 50. So I can say that value is 50. If I have to take common 1 plus 1, that is 50 root 2. 50, sorry, 50. So there is a, yeah, let me just calculate it for the sake of clarity, just to tell you that what I mean to say. Yeah, here this is root of 50 square plus 50 square. That is equal to, if I have take 50 square common, 1 plus 1 is 2. So 50 square out of the square root is 50. So the answer is 50 root 2 kilometer per hour. The value of that root 2, 1.414. If you multiply, I will get 70.7 kmph. I need not even calculate because it cannot be 0, it cannot be 50. They are definitely ruled out. Other than that, there is only one number that is available, 70.7, that I can blindly take, right? But what is the direction of this vector is, right? That's now we further needed to find the direction of the vector. Finding the direction of the vector is very simple because we already found the change in velocity as change in velocity or increase in velocity is minus 50 I cap and minus 50 J cap. Minus 50, where is that minus 50 means? Minus I cap means what? It's along west. And minus J cap means it's along south. So your resultant vector is definitely in between south and west. So south and west is the right direction. Northwest is not the right direction. So your answer has to be 70 root 7 along southwest. That's the answer for the problem. Your vector will be somewhere here. That v2 minus v1 will be somewhere there. That's it. That's how you have to solve the problem. Thank you for watching.